I'm going to talk today about SQL. And no, I'm not talking about the second part of a movie. I'm talking about the structured query language. Keep watching and we're going to talk about how much SQL you need to be a successful data scientist, and I'm going to give you some hopefully pretty helpful resources. I'm Richard and this is RichardOnData. So it shouldn't come as a surprise to absolutely anybody that SQL is one of the highest in-demand skills for data scientists, and you're probably going to have to use it on the job at least to some extent. Now, a while ago, I did a video where I laid out a study pathway for data science, and I listed 3 absolutely essential things which any data scientist must know, and then I followed it with 4 other things which are very helpful, but maybe those are optional and they can come in order of personal preference. I put SQL as the second most important thing on that list, with the only more important thing being statistics. Yes, I even put SQL ahead of R or Python. Now, why did I do that? Well, a big reason for that is because SQL is generally thought to be easier to learn than R and Python are. There's just less stuff in it that you need to get really good at. It's not littered with packages that you need to get familiar with, and you can think of it syntactically as kind of even similar to the English language. Also, to do any kind of complex analysis, you need to get your data into a usable format first. So you're probably going to query your data from a data warehouse or database, and that's typically going to come from multiple different tables. But SQL certainly does have some depth to it, so it's definitely worth asking the question of how much SQL exactly do you need to know? Because for the overwhelming majority of data science jobs, you probably don't need to know performative SQL at anywhere near the level that data architects or database engineers do. So I'm going to step through 10 SQL items that I think are important. And obviously, this is not going to be a comprehensive list for every single data science job on the planet. But for most people, I do think if you know all these items, you're going to know more than enough SQL for your daily job. And who knows, maybe even you'll be able to impress the person who's asking you SQL questions in an interview. But before I do that, just a few small requests. Please subscribe to my channel if you haven't already, and also take 1 second of your time to smash the like button. That really helps my content reach a larger audience. Also, I will have a link in the description of this video to my Patreon account. If you're willing to go and support me that way, it would be massively appreciated. Alright, so we're going to start with the absolute fundamental basics, and those are the select, select distinct, from, where, and order by functions. And this is the part that reads more like the English language than anything. You select your columns from a table in your database where certain conditions are true. That's all there is to it. And then occasionally you'll want to keep duplicates, but sometimes you don't. If you don't want the duplicates, then you just need to throw the distinct in there. Select by default will keep all the duplicates, whereas if you do select distinct, it just eliminates the duplicates. Now, the where clause is a pretty flexible and powerful one, and it's typically going to be used with a word like and, or not. So naturally, these are going to allow you to create the conditions you need for filtering rows based on the observations you have in one or more columns. But then you've also got the like phrase, and this is going to be super critical to have when you're working with text and strings. Now, you can also use this with wildcards, and the SQL syntax for these are percentage symbols, as they are in most languages, and you can use these to cut your text in either direction to filter on matches. Then you also have the in and between operators. Now, where in will allow a column to take on multiple different values. Where between is for continuous variables, where you want the value to fall between one value and another. Order by is an optional addition here, and it's really not always something you need, just because it does have a tendency to cause some pretty serious slowdown if you have data that's on the bigger side. Having said that, it is a foundational one to know, and naturally, you can use it to return your records in either ascending or descending order. So, okay, you've got your data selected and filtered, maybe even you ordered it. Now, next step, you've got to summarize it. And that's where the group by function and various summary functions are going to come into play. There's all kinds of summary functions, and I'd say the most common one is the count function that literally just returns a count of the number of rows. But then some other pretty common ones are the AVG and sum functions. These are good when you're working with continuous data. These will give you the average and the sum, respectively. But I'd wager a guess that the overwhelming majority of the time, you don't want one summary number for your entire data set. You want to do a grouped summary. That's where the group by statement is going to come in, and it's going to help you to run any of these summary metrics grouped by unique values from another column. And again, that's the majority of the times you'll need to run these summaries. So get very comfortable with it. And also just remember the group by comes after the where clause. I always used to forget that. Now there's also one more nuance. Summary functions can't be used with the where clause. SQL has a different statement called having for that. See this situation here where they do a grouped count, but they only want to return the cases where the count of customers is greater than 5. So they use the having clause. Not a big deal, just something you've got to remember. And that brings us to another one of the absolute foundational items of SQL, and that is, of course, joins. It's very rare that you're just going to have one clean table. You probably are going to have multiple tables which need to come together into one, and that's where joins come in. Now there are multiple different kinds of joins, but the overall principle is going to be the same for all of them. You're going to merge two different tables together, or at times you're just going to have a sequence of joins to bring multiple tables all together, and you're going to join based on a common matching value for a column that's in both tables. Here's the main types of different joins. Now, inner join is the default one, and that's going to keep only the records in which there's actually a match in both tables. The left join and the right join are the exact same thing, just with a different order of the tables. And you can either keep all the records on the left side or the right side, and then cases where there's no match are nulls. That's all there is to it. And then I can count on half of my one hand the instances in which I've needed to use an outer join, but I suppose that's a good one just to be aware of too. It keeps all the records in both tables. And there are a couple of other types of important joins. One that I've used a few times is called the cross join, and this basically gives you the Cartesian product between two different tables. It's going to spit out a table with the number of rows equal to the number of rows on the left table times the number of rows in the right table. And this is a pretty helpful tool if you're making something like a seed table. So it's really important to get extremely comfortable with joins, because these are literally what SQL was designed for. You're creating a merged data set by working with sets of rows all at the same time. Alright, so now you know most of the key functions. You're able to take different data, join it, filter it, group it, summarize it, all that good stuff. Well, a lot of stuff in SQL cannot be done with just one single query. Often it's going to be necessary to run one query, store the results somehow, and then use the results of that query to join or filter or whatever you need to do to the results of another query. And there are multiple ways that you can do this, and I'm going to talk about 3 of them here. Those are subqueries, temp tables, and CTEs. Here's an example of a subquery. And now these are not always the easiest things to read, but generally the best approach is to read them from inside out. So we're going to do that here. You've got a student ID equal to V002, and we extract the column total marks from them. Then we join 2 tables and filter based on that result. So we only return rows where the student's total marks is higher than the one inside our inner query. So we're using a result in our inner query to filter the results from our outer query. That's really all there is to it. Now we also have what's called temp tables, and we have what's called common table expressions, or CTEs. And these essentially serve the exact same purpose that subquery you saw does. That is, we're running one query and we're using the results of it, we're accessing that to influence what we're getting from some other query. I'm not going to go much into the difference between temp tables and CTEs here, because quite frankly, both of them will work for the vast majority of problems. However, it is important to know there can be some pretty serious performance differences between subqueries, temp tables, and CTEs. And honestly, the specific instances could be the subject for a different video in and of itself. But rather than be intimately familiar with all the situations in which one is better than the other, I think the most important thing for most data scientists is just to be familiar with all the three approaches and be able to interchange them quickly just to tune your query for performance. Here's an example of a CTE. And now these are created using the with statement. And the thing with them is you have to immediately access the results using a statement like select. You can also use insert or update or delete, but I think the majority of the time you're just going to be selecting from them. And you see here they create one CTE from person information data using things like first and last name. Then they create another CTE from phone number data. Then they join the two on the common business entity ID. Now CTEs are my personal favorite of these three methods, but again, get familiar with all three of them. Temp tables are a similar idea, except you can access them outside of the context of something like a select statement immediately afterward. One nice thing I will say with CTEs is you can use them for recursion to loop through your data set, but I do think that's going to be way more advanced than what most data scientists are going to need to do using SQL. Next up, we have two of the most powerful and flexible functions in SQL, and that's CASEWHEN and exists. And I'm grouping them together here because together they make an incredibly powerful combination. CASEWHEN is the equivalent of an if-then-else statement that you might see in something like Python. And as you can imagine, you'll use this a lot for mapping different values of some variable to a different variable. Like in this example where they're going from a quantitative variable to a text string. Pretty straightforward stuff. Exists is typically used in the where clause, but personally, I love using it with CASEWHEN. Here's an example illustrating how these two work together, and using this can be a lot easier than doing joins, particularly when you're doing this multiple times. So in this example, they pull a couple columns, and then there's a rule where if that record exists in a separate table, then return the value person. Otherwise, return the value not a person. Pretty clean, pretty fast, pretty easy to use. And now related to those last few concepts, it'll happen sometimes that you need to leverage the information inside of a table against itself. And that's where it'll be helpful to join the table to itself, or as is commonly called, the SELFJOIN. Here's an example. We pull the customer name column, then we pull it again, and we return instances where those two customer names are not the same, but the city is the same. And in effect, what this ends up doing is you're basically returning all combinations of customers that are from the same city. So there are more complex instances where you're going to need to do stuff like this, but this is a simple example that illustrates the point. Alright, so by this point, you're getting pretty good at SQL, and you should be able to cleverly manipulate the rows and columns of various tables to get a data set that's in a format that you need it to be. Now, the next couple things that you need to get familiar with are stored procedures and UDFs, that is, user-defined functions. And these are convenient ways of storing SQL code directly in your database, so you can use them over and over again, or at least you have that code stored so it's there whenever you need it. And I'll have a link in the description of this video detailing the difference between stored procedures and functions, but they are pretty functionally similar. The single biggest difference is that functions can be used directly inside of statements like select and where, whereas stored procedures cannot. So here's a really simple stored procedure example. So they create a procedure which selects from the table called customers. And now stored procedures can have optional parameters, and they use those here to set the data columns city and postal code equal to values that are provided when the procedure is called. So we create this procedure and it gets stored, and then we can use it with the exec statement. So in this example, we've stored our procedure, we execute it, and then we've got our table. And again, this is a simple example, but creating these is critical if you intend to run a chunk of SQL code over and over again. Then alternatively, also, if you have multiple users who are working in the same database and you want to share your code, it's a super convenient way to do that. Next up, we have window functions. And these are pretty similar to the summary functions we talked about earlier, but these are in a class of their own because specifically what they do is they work on the other rows of your table relative to your current row. One example is lead, which pulls a value from the next row into the current one. There's also lag, that pulls a value from the previous row into the current one. But my personal window function is row number. So let's see an example of that. So here the first thing we're selecting is the row number function. We order by first name and we're adding a column for that row number. First name is Aaron, that gets a 1. Second name is Abby, that gets a 2, so on and so forth. That's all there is to it. Now you can add the partition by clause, and that's going to function kind of like the group by statement. Just as an example, you could create row numbers, again, for the order of first name, but partition that by city, just as an example. Number 9 on this list are the useful pivot and unpivot functions. So for those of you who are familiar with the concept of long and wide data, pivot and unpivot are designed to help you alternate between the two. Specifically, the pivot function helps you go from long format to wide, and the unpivot function helps you go from wide to long format. So think of these like the spread and gather function in the tidyr package of R, if you're familiar with that. As usual, let's look at an example. So in looking at this code, let's actually start a couple lines down. So they pull 2 columns. Those are days to manufacture and standard cost. Now the average for standard cost is taken for each value of days to manufacture, where that variable is equal to 0, 1, 2, 3, or 4. Then the pivot function coerces this to have 1 column for each value. And there's a select statement on the outside of this just to run the query. Then if our data were just presented like this, we could use unpivot to succinctly just get 1 row per observation. So that's no problem either. Now you don't necessarily need these functions to go from one format of data to the other, but they're going to make your life way easier. Alright, and for the last item on this list, we have one that's purely performance oriented. So it will happen if you're working with large data sets, and particularly if you're doing things like joins or subqueries, that your code can take several minutes, sometimes as much as hours to run. Well, one tool for helping with this kind of problem is the index. Think of these as like a lookup, kind of like the index that you might have at the back of a book. Now, if you were searching for multiple things, rather than scan through every single page of that entire book, if you had that index at the back that tells you exactly where things appear, that's going to save you a ton of time. And that's completely analogous to what an index in a SQL query or stored procedure does. So if you create an index on a column that you're searching for often or that you're joining on, you might just dramatically speed up your query. And there's 2 main different types of indexes, and those are the clustered index and the non-clustered index. Now there's a lot of difference between the two, and again, that could be the subject of its own video. So here's a good table from the website Giant Stride, which I think does a decent job comparing the pros and cons of the 2 versions of indexes. And again, I think rather than a data scientist intimately knowing all of the instances in which one is better than the other, the absolute most important thing is just being aware that both of them exist, to be able to look up information like this, and to be able to use either one when necessary. And now, as I promised at the beginning of this video, I'm going to throw some resources for learning SQL at your direction. A lot of the pictures that you've seen in this video come from w3schools.com, and this is an awesome resource for learning tons of different programming languages, but it's particularly nice with SQL because you can write sample code and interact with data directly in your browser. I personally learned a lot through the book The Guru's Guide to Transact SQL by Ken Henderson, and I'll have an Amazon link to that in the description. And then naturally, there's no substitute for practice and experience. And there's some great exercises and challenges on the website LeetCode. As usual, link in the description. Now, once again, there are tons of things that I'm leaving off here. And one example is cursors. My best advice on when to use cursors would be this: you don't. But I really think if you know all of this stuff, you'll be able to get your data into virtually any format that you want. You'll be writing code at an intermediate, maybe even borderline advanced level. You'll be able to get your code to perform at a reasonable speed. And naturally, you'll have the notions down of writing reusable and reproducible code. And then you're probably ready to move on to the next big thing. Maybe that's R, maybe that's Python, maybe it's something else. Who knows? The world is your oyster. So thanks for watching this video. If you enjoyed it and you'd like to support my work, it's super helpful for me if you share this video. Otherwise, hit the like button and also leave me a comment down below and tell me how much SQL you've used in a data science job. Then I'll see you all in the not so distant future. Until then, Richard on Data.